Hi, in this video I will explain homework 5 question number 1 and 2. So first let us look at question number 1. Question number 1 is to find out the area of fz where z equals to x plus y uh, in convolution method and by geometric method. So let us first look at the method by convolution method. So fx is defined as step functions, that u of x minus 1 minus u of x minus 2, and its graph is like this. And fy is also defined in terms of step functions, that is u of y minus u of y minus 1, and this is fy's graph. So z is x plus y. So how can we calculate the fz in terms of convolution method? This is easy. So as we know that x and y are random variables, so independent random variables, we can write fz equals to fx into fy. So before that, what we will be assuming, that we will be assuming fx and fy are actually defined in the same region, that is fx is also ux minus 1 and fy also uy minus u minus 1. And at the final result we just need to shift the whole result by one place to the right, because the original definition of fx was actually u of x minus 1 minus u of x minus 2. So we put the so in convolution method, this is the approach. We put the values of fx and fy, and we do some multiplications and arrive at this equation. So from this equation we actually need to update our limits of the integration, because this is u of alpha. So we can see that the limits of this integration should be changed from 0 to z, because this is u alpha, this means the lower limit is 0, and this is u of z minus alpha, so this means the upper limit is z. Similarly, for all the integrations, the limits are updated as 0 to z minus 1, 1 to z, and 1 to z minus 1. Now we can define these functions in terms of step functions as uz, because the limits are 0 to z. Then these should be defined in terms of uz minus 1, because the limits are 0 to z minus 1. And then all the integrations are defined in terms of step functions, and finally we arrive at this final form for fz. So now we just need to shift fz by one place to the right, because originally fx was u of x minus 1 minus u of x minus 2. So the final answer for fz equals to z minus 1 into u z minus 1 minus 2 into z minus 2 into u minus z minus 2 plus z minus 3 into u of z minus 3. And this is the graph of fz. Now let us again do the calculation for geometric method. So we will be assuming the same thing, that fx equals to u of x minus u of x minus 1, and fy equals to u of y minus u of y minus 1, and the final result would be right shifted by one place. So how we can calculate the fz, capital Fz of z, that is nothing but probability of z less equals to z, that is probability of x plus y less equals to z. So now we can actually divide this computation into three parts, that is z less equals to 1, z lies between 1 and 2, and z greater than 2. So for the first one, z less than 1, pardon me, there should be a square actually, unit square. So z less equals to 1. So the probability that x plus y is less than z, this is nothing but the area of the shaded region, and this area of the shaded region is nothing but z square by 2, and we can get density function of fz equals to differentiation of capital Fz equals to z. So when z lies between 1 and 2, how we can calculate the area of this region? Because now this line is actually, this complete area is beyond the unit square, so we are only concerned with the area within the square. So how we can calculate it? Actually the area of the square is 1, and from this one we can just deduct this small area. So what is the area of this small triangle? This is nothing but, this is actually, you can see this area is z minus 1, so this is also z minus 1, and this is 1, so 1 minus z minus 1, which is nothing but 2 minus z. So the area of this triangle is 2 minus z whole square by 2. Area of this small triangle, the area of the triangle, the area of the shaded region is nothing but 1 minus this area, so which turns out to be minus z square by 2 plus 2z minus 1. So we can take differentiation of this one, and we will get the small fz, that is the density function, equals to minus z plus 2. And when z greater than 2, we know that this is fz would be 1, so small fz is 0, the density function is 0 over that range. So yeah, so for this the fz is defined as this. Now we need to shift our result by one place to the right, so this would be this from 1 to 3, and fz can be defined as z minus 1 into u z minus 1 minus 2 into z minus 2 into u z minus 2 plus z minus 3 into u z minus 3, same as above. So that's it for question 1.